Welcome to another math video. Oh my goodness, it is you. The little kitten. Now I want you to know, I thought for sure, since I took the kitten to a really nice home and thought they were going to take care of it, somehow that kitten found its way all the way back to my house. Okay, this is just, I got to give up. Cats just must rule, I guess. I don't know. I mean, I haven't seen my dogs in I don't know how long. Anyway, hey, enough with the avatar. Look at here, another cat. Can we just, yeah. Well, maybe, should we shrink you and just keep you here? I don't know, I suppose we could. Or we could go, delete. All right, so let's go ahead and get started with this math video. And as you can see, we're doing Module 2, end of Module Review, Part 2. And basically, we're doing a lot of what we've been doing in the whole module. So let's just go ahead and get started here. As you can see here, it says that Jacqueline says that 41 divided by 9 equals 37 divided by 8 because both are 4 remainder 5. Now explain her mistake using decimal division. So this is pretty clear. Jacqueline, this is what she's claiming. Well, I don't even know if that's true. So let's go ahead and just even see if that's actually true. Let's take the 41, and we'll do that 41 divided by 9 over here. We'll go ahead and do the 37 divided by 8 over here. All right. Ooh, I love that color. So it says basically, well 9 will go into 41. I wonder if it'll go in 4 times because that's what they're claiming. 9 times 4 is 36. Put my 36, I subtract, and as you can see with a little bit of regrouping here, what do you know? The answer to this one is 4 remainder 5. Jacqueline, I think you're on track. Oh, of course, she says they're equal. Well, let's go ahead and look at the other one. It goes into 37 5 times? No, it does not. It goes in there 4 times, which is 32 remainder 5. Oh, here we go. So are these equal to each other? Well, maybe at first glance one might think that they're the same, but actually it says explain to her making. Yes, Mr. Wara, that word really looks like making. Explain her mistake using decimal division. Okay. Well, let me see. I don't know if I can do that. I've been out in the surf all day, dude. I don't know. I'll try. All right, let me wax my surf. Mr. Wara, come on. The surfer dude, leave him out on the beach. We're focusing on why Jacqueline is saying these are the same, and indeed they're not. And I have to show it using decimal division. Okay, so don't panic. Okay, so let's go ahead and rewrite our numbers. I'm going to just show a little line separating this, because I think it would be kind of cool to have a line, basically, Yeah, it looks cool. Thank you. I know, that was a good call. Give it up for Mr. Wara. You love the line. That may be the best line I think I've ever done. I'm going to give you a star. Thank you. Anyway, so here we are with our 41 divided by 9, but we have to use decimal division. Well, since we can't have that little r is, 5, that means we got to put in our decimal, that's all. And already, I don't like that I put that up so high. Mr. Wara, what were you thinking? Lower that a little bit. Lower. Thank you. All right. Much better. And let's go ahead and continue on here. So then I can put a 0 here. I don't know if I'm going to need a couple, but I'll put 2. I could always add more because it doesn't change this value at all. So now we're right back where we were. We have 4. Okay. And that would be 36 like we already determined. And now we have remainder 5. So now we need to bring down this 0 to continue on for decimal division. Well, 9 goes into 50. Last time I checked, 5 times? You go with that? Which is 45, which leaves us with a remainder of 5. Now, everything there looks fine. We bring this down. Uh-oh. Do you see a pattern here? Now, this is going to keep going on and on and on. Okay? Now, not the nicest decimal in the world. I'm going to just teach you a little something. This is just called a repeating decimal. I'm going to put that line above the decimal. You don't really need to learn that in 5th grade. But I was trying to find numbers that would work for this activity. And so, anyway, since this is based on the assessment, this was the best I could do. Well, that means that this is basically 4.555, or you could round this to the nearest tenth and say that that's 4.6. But let's just leave that there for the time being. We'll come over here and do this one. Okay, and we're going to divide that by 8 here. Definitely. Now, we need to put the decimal in, just like we did before. 8 goes into 374 times. That's 32. We take away. We end up with 5. We bring down the 0. Ooh, that 50 is pretty popular, eh? 8 goes into 50, though, I think 6 times. Give me 48. Okay. Leave me with 2. Bring down my 0. And you can see that's going to go in there twice. That's 16. And I suddenly ran out of room. Come on here. Okay. Now that leaves me with 4. I can add on one more 0. And look at that. 8 goes into 45 times. Now, by looking at this, what I've basically done is I have proven that Jacqueline did make a mistake, because this decimal here, and even though I could go to try to check my work, I'd have some difficulties with that repeating decimal, but don't worry about that. But by just looking at that, you should be able to see right away that this is 4.6 and this is 4.5. Okay, so indeed, the quotient is larger here on this problem. But the biggest thing that we actually were able to show, which was the question, was basically to show how it's not the same. Oh, you know what? I never thought of a good word to use for code word. I'm going to have to give this some thought here. Let me think. Okay, I'm not sure if I use this one or not. I don't think that I did. But either way, maybe it would get used again. Thank you. Got that? Just that one there. All right. So let's see what else we got going on here. Oh, look at that. The cats, they're like in the corner. They're kitty corner. Get it? Yeah. Okay. Not a very good joke, Mr. Okay. I'm sorry. I'm working on my material. Hopefully I'll get some better material very soon. I have this guy who writes all the jokes for me. So anyways. Yeah, they're just everywhere. The cats are just pretending like they're not there. Now we have this problem where it says a rectangular playground has an area of 2,888 square meters. If the width of the rectangle is 25 meters, find the length. Oh my goodness. Easy peasy. What is it? Lemon squeezy? Oh, this is, I'm going to get my shape because I want to get busy right away and show this problem. There we go. And then I'll come down here and let's get busy here. We're basically saying that the area, that's what's in the inside, is going to be meters squared. And I'm going to actually do this instead of writing the square meters a little bit faster. Now it says the width of the rectangle, and we'll say this is 25. Okay, but we just don't know what the length is. Pretty easy, considering we know that area equals length times width. We know that. Of course we do. Or at least I know this. No, of course you guys know this. I'm only saying this because I'm right now presenting the lesson. So if that's area equals length times width, well then here's my area. So I'm going to take that and divide that, okay, by my width, because I can do that, okay, by 25. So far, so good. I think so. And now I'm going to come over here and go ahead and solve the division problem. 25 goes into 28 really nice, okay, which is really 2,800 when we look at the larger number. But how many times will go in there? What's going to go in there? One time, okay, and that's going to be 25. And then we're going to subtract and we're going to get 3. I do believe. And now I'm going to bring down my 8. Okay. Now 25 is going to go to 38 one time. This is really easy, Mr. Wara. Boy, you pick all the easy ones. I know. And this number keeps ending up being smaller than my divisor. Therefore, I know that I took out the right amount. Now I can come down and drop one more 8. Okay, now I have 25 into 138. Or what I like to say is how many times 2, which is actually 20, into 13, which is 130. Well, 6 times it should go in there. Should. But wait a second. 4. No, it won't go in there 6 times because 25 is, 25, 4 quarters and $1. 25 times 4 is 100. You get one more. That would be only 5. And then basically, we would say that that's 125. Now I'm still getting a remainder of 3. Now, I'm going to go ahead and put my decimal here because I need to kind of continue on. I can't just put remainder now because I need to find what the length actually is. I can't put, 115 remainder 13. That's not an accurate, we need a decimal. So, knowing that, needle and thread, I'm going to go ahead and say, drop down that 0. And now it's going to go in there again. Look at that 125, so it's going to go in there 5 times. And that's going to be 125. You know what? Buddy, you're kind of like in my way now, As sophisticated as you look like sitting there, I'm going to have to move you. Sorry, buddy. Go on in there. Don't take it personal. No, just kidding. You guys in the same family. You guys would get along. Just kidding. Mr. Ward's just having some fun. Kind of at your expense, though. Woo! All right. And that leaves me 5. Okay? I was wondering if this was ever going to solve, but it is. Now I bring down another 0, and look at that. 25 will go into 50. Woohoo! 2 times. Thank goodness. I didn't know if that was ever going to end. So that means that the length would be 115 and 52, or 0.52 meters. Ooh, I didn't even put the unit of measure here. I'm surely glad nobody challenged me on that one. Or at least I didn't hear anybody. So, and that makes it 50, brings down to 0. Now I can double check my work because it says that length times width equals area, so now I can do the reverse. Ooh, it's a lot of work, but somebody has to do it. All right, multiply. I'm going to just leave the decimal in at this particular time. I've been doing it kind of both ways. Hopefully you'll get used to both ways. That's 26, I believe. And that's 25. That looks like 27. Carry the 2. 5. Ooh, that looks like 7. And then 5. Placeholder. Then I have 4. 10. Ooh, right at 10. That's 11. Carry the 1. That's 2. 3. And then finally 2. And now I have 10. Carry the 1. Oh, that's 8. 8. 8. 2. That's looking good, but ooh, I have 2 decimal places to. There we go. 2888. So we won. Yeah. Well, I say we. Yeah, we all won. Did we on that one? Okay, you. Okay. Now let me see here. Next page. Oh, it's a blank page. All right. I got to pull this thing down here. What's going on back here? Okay. Oh, whoa, 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 whoa. What is this? You gotta be kidding me. Really? You find that comical, do you? Smart software has taken over, It's one thing when the pen's a little glitchy. It's another thing when it does stuff like this. And, hello, like what's this doing in here? Oh, they're cattails. I get it. Cattails, get it? Oh, my goodness. I'm going to have to start deleting some of you guys. And what's this thing? Oh, it's a catapult. Okay, don't laugh all at once now. All right, we're going to get rid of the... And a cow, what are you doing here? I don't know. I don't see how that one's in here. I think you're smart. You goofed on that one there. Oh, my goodness. Delete, delete. Sorry, cats. Bye-bye. Ooh, the one that was snoozing. Never saw him before. Oh, my goodness. Catfish. All right, this is just too much. You know what? Yeah, you're right. Mr. Ward's having a fun with this. Yoo-hoo! Yeah. Now, I don't know why it says this mid-module up here. This isn't right. This should be end of the module. Oh, I didn't want to shake it. I just wanted to change it. Okay, this is the end of module 2. Anyway, so here we go. Let's go ahead and do one more problem, and I believe we'll be really already done here. I got to keep thinking which letters did I already use. I think I need one of these if I'm not mistaken. Yeah. Got to think in my head. See, I never write these down. I really should. Anyway, move on, Mr. Wara. So now it says a baker. Okay. Uses 8.5 pounds of flour daily. Okay. It says how many ounces of flour will he use in 2 weeks? Now you have to use words, numbers, and pictures to explain your thinking. That's a lot. Well, I have to write something. I have to show my work with the numbers, I guess, and pictures. This does not have the word or in it. It has the word and. This conjunction means it's all inclusive. So we have to do all of these. Now if it said use words or numbers, okay, then you could choose one or the other. All right, I need to explain that because, that's really important. Believe it or not, later on when you get into geometry and you start talking about sets and subsets, and this is going to be really important to understand the difference. So, or's not conditional. This is. You have to have all of them. So let's go ahead and get started here. And first put, well, we know that the 8.5 pounds is going to equal, we don't know. so many ounces, right? We need to determine that. Now, they actually provided that. That was kind of nice of them to do that. I don't know what this whole thing here is for, but it looks like we have something there. I'm almost scared to open it up. Should I open it up? No, don't do it. What is it? Oh, it's just a rectangle? Okay. Whew, thank goodness. That was something else. Okay, so come down. So basically then here, this is, the way I want to look at this one here is I'm just going to go ahead and say that, well, if 1 pound is 16 ounces, I should be able to just take 8.5. Okay, now I multiply that by 16. I'm going to leave the decimal in there. I could take it out as long as I put it back in later, but I'm going to go ahead and leave it in. 30, and then that's going to be 48, looks like 51. Placeholder 5 and 8. And therefore we have 0, 6, and then it looks like 13. Now, this is going to be ounces now. Okay, and does that seem reasonable? 16 times 8. Yeah, that put me about 15, 8. Yeah, that seems like it's about, could be about right. Oh, wait a second. 8, 16. Decimal point. Haha. 136. Yeah, I started saying 16 times 8. I'm not getting up to 1,000, Mr. Wara. Come on. Use some reasonableness of math here. So that tells me that that would be 136 based on that. So that's how many ounces I have. Well, that's helpful because we're trying to figure out how many ounces he's going to use in 2 weeks. So when I kind of think of a picture, this might be where we might want to do a tape diagram. We could, you could show that, because basically, this kind of stuff's kind of all over the place. Since I already have this answer, I'm going to just kind of group this and totally do this shrinkage. Okay, wow, did that get small? Okay, and then I could kind of open this thing up a little bit more because I need some place to write too. Okay, and I'm trying to make sure this video gets done in a certain amount of time here too. So here we have basically, so we're basically fitting it daily. So 136, that's basically our unit. Our unit is going to be 136 because that's per day. And you can see that, if we do brackets, that would be 1 day, that would be 2 days. Sometimes, we put it in the inside, same kind of thing. And then basically, we're going to have a total of 14 days, right? Would you agree? 2 weeks, 7 days in a week. So basically, we're going to get all the way to the 14th one, okay? Which, that one's also going to be 136. So it's just a quick little tape diagram to kind of show you what's going on. And of course, this amount right here is going to be the total. This is what we don't know, how many ounces in 2 weeks. That's what we're trying to figure out. So now let's go ahead and take our numbers. Let's take 136. We're going to multiply that by 14. That's 4. Carry the 2. We have 12. 14. Carry the 1. 4. That's 5. Placeholder 6. 3. 1. Now we have 4. We have 10. 8. 9. So it looks like 1,904 ounces. It doesn't tell us that we have to put it back into pounds, but that's actually would be very reasonable for that number. So I'm going to do here real quick is group this. It looks like it was grouped already. Perfect. Kind of put it down here. Make it a little bit smaller. So little. Okay, and then come over here. Let me go ahead and just get another color here. So we could actually take this and divide it by 16. That goes in there one time. Hopefully this will be easy math. Almost twice, but not quite. Okay, and then we got basically 1, looks like 4. Yeah, that's what looks right. 14, yes, it's less. Then I put 4 in there. How many times? About 7. I don't know. I'm totally estimating here on that one. 7. Ooh, close, but not quite. Another 32 would be 144 exactly. So 9 times. And I think that should be it. Okay, so it gives us 119 pounds. That seems like a more reasonable answer to give. So basically, now I got to explain. So let me go ahead and get my pen. And in the meantime, I need to do this. Ooh, let me see here. Yeah, let's do this. And let me get a different color, like blue. Okay, I'm going to try to write neat. Okay, so I always start off with my subject, okay? First thing I had to do was I had to find the ounces first. Let me put that on there. I found... Okay, the ounces, just put O-Z, Oz. I found the Oz, well, should I say ounces? Yeah. I found the ounces he uses here, okay? Daily first, or every day. Okay. Every day first. Okay. Kind of sloppy. And then I just multiply that, okay? Then I multiplied by 14. Okay? And then finally, so we can say that the baker uses, and then he used, I'm going to say 119 pounds. It does not have to be in pounds, okay, of flour in 2 weeks. All right, kind of whip through that quickly. And where did I leave off? I think I left off there. I sure hope so. And I did notice in my head. So I think that covers this. Now we're going to, in the next video, we're going to be doing more problems from this. So we'll be reviewing that one more time. I think this pretty much concludes our video and the massive cat invasion of this video, I might add. I still have cat scratches all over me. Oh my goodness. All right. So, till next time, my friends.